So oscillation and waves, again, this will be doing together because mostly this is similar type of formula, similar type of function. Oscillation is for one particle only, and waves will be the oscillation of many particles of a medium simultaneously. That will produce a wave. So motion is periodic and non-periodic. Periodic which repeats after a regular interval of time, and non-periodic which does not. Periodic motion is any type of motion, straight line, circle, rotation, spring, vibration. If it satisfies the condition that it will be repeated after a regular interval of time, then it will be called periodic motion. The minimum time is called period of the motion, and every n times t, after every n times t, the function will attain the same value. Oscillatory motion is one category of periodic motion, one class. So oscillatory motion is the one which is to and fro about a fixed position, fixed mean position, and it requires only that condition. Force has to be opposite to direction of displacement. So when body is displaced in positive direction, force should be negative. When force displacement is negative, force should be positive. Right? Okay. Now oscillatory motion example, like the motion of a body, of a particle dropped inside the tunnel across Earth's diameter. I'm taking that example because this motion is oscillatory when the particle is dropped from outside above the tunnel. It will go inside, cross the center of Earth, and then goes on the other side. So when this particle is up, the force will be acting toward the center. When this body is downwards, then force will be upwards. Force is opposite to displacement. That is the condition for oscillatory motion. So there is no requirement of force to be directly proportional to x. Any type of force, like the spring force, इसमें अगर हम displacement लेते हैं, let's say x, then what is the formula for force? It is gm1 m2 upon x square. So it is inversely proportional to x square. This motion is also an oscillatory motion. So apart from that, so there can be any type of function, but there is one special class that guarantees motion to be oscillatory, and that is if a force is proportional to minus times odd power of a displacement. K is some force constant, and if it is an odd power, 2n plus 1 is odd number when n starts from 0. Right, so if we put n is equal to 0, then it will become minus kx. If we put n is equal to 1, then it becomes minus kx cube. If we put n is equal to 2, then it becomes minus kx5, and so on. All these conditions, all these forces are when the particle starts from its mean position x equals to 0. So when it is at a position of x, displacement from mean position will be x only. Force has to be proportional to odd power of displacement. That is the condition for motion to be oscillatory in nature. If the mean position is shifted from origin, suppose did I समझ में आ गया ना? Priti?
Yes, sir.
How are you?
Sir, I'm good.
Okay, you are solving questions from previous years?
Yes, sir.
Okay, I am just rushing for the syllabus because after that we will be focusing only on the doubts. So I'm not able to interact much because I want to quickly finish it. Okay. Yes. So anything you don't understand, please note it down, or you can ask in the class also. But because of the very short time available, I'm just trying to cover each and everything, at least a concept wise. Question you have to practice from your side and keep all the doubts. We will discuss after finishing this. 12th, I know 12th will be quite comfortable. 11th may be a little bit rusty because of the time and concept involved in class 11th are more concept oriented. 12th is mostly formula oriented, other than the ray optics. Only ray optics is one tricky portion in class 12th. So that's why I am asking you guys to solve previous year questions only as of now. If you are able to solve all the questions, feel very happy and confident. I'll be able to solve an exam. After let's say 20th of August or 25th of August, every day will be just a revision come doubt class. I mean, doubt session only, doubt session, because doubts are more important for you to clear the doubts of all this. But it should not happen that when we finish, then you start preparing. So do it every day along with the class. Due to the time limitation, we cannot solve questions in class, many questions, but any tricky one we will be using. अगर suppose हम mean position shift कर देते हैं, if mean position of the particle is, physics is the only culprit in especially the medical entrance. So don't let it be your rank destroying subject. 150 plus is very easily scorable in physics out of 180. This is for the NEET guys. And 170 to 172 you can score if you do a little smart work and you know how to and which question to solve and which question to leave. So that paper solving strategy also we will discuss in the last few weeks. Mean position is shifted. It is not at origin, it is x equals to x naught. Say if a position x equals to x naught is mean position. Mean position means there is no force at this position when the particle is shifted to x. The displacement is x minus x naught. F is equal to minus k x minus x naught to the power 2n plus 1. That is the condition for the motion to be oscillatory in nature. Now, if the force becomes directly proportional to displacement as well, then it will become harmonic motion or rather simple harmonic motion. Simple harmonic motion is one category of oscillatory motion. So those oscillatory motion in which force is proportional to displacement and act in opposite direction, those are called simple harmonic motion. F is minus kx if origin is the mean position, or it has to be f is equal to minus k into x minus x naught if the mean position is at x equals to x naught. Right? So mean position is 0, then f is equal to minus kx. If f is equal to minus kx minus x naught, mean position is x naught, then it will be f is equal to minus k into x minus x naught. Force is proportional to minus of displacement, and since it is opposite, hence it is called restoring force. This is called restoring force. Right? Acceleration will also be proportional to minus of x, because if we divide it by mass, acceleration is f by m, so that becomes minus kx by m. K by m is a constant which is written as omega square. Omega is called angular frequency of SHM. Root K by m is angular frequency of SHM. So from omega we can find out the time period also. Time period is 2 pi by omega. Why it is omega? That is also another concept. Because omega we use for the circular motion as a constant angular velocity. Here this omega is related with some circular motion and that we will see in the phasor diagram. Acceleration को हम displacement के terms में in the form of differential equation d square x by dt square is minus omega square x or the double differentiation of displacement. So this is called differential equation of SHM. Now on solving this and how it's solved, that is not in our syllabus. So that is some differential equation higher order. So there is standard solution and the standard solution of this is x equals to a sine omega t plus phi. This is a standard equation which will satisfy this type of second order differential equation. Now A here is the maximum value of displacement. Similarly, the other equation, if we have the mean position shifted at x naught, then also equation will be same, but displacement will be written as x minus x naught, that is equal to a sine omega t plus phi. Right. So that means it is x represent here what displacement. It will be decided by what is the initial position, and so in this equation that we'll use only that a sine omega t plus phi. In all the rest of the equation we can directly write x replace x by x minus x naught. Mean position x naught. A here is the maximum value of displacement which is called amplitude. So if motion starts from x equals to 0, it moves to a certain position of A. A is the maximum displacement possible. So this maximum displacement is also called as amplitude. Capital A is amplitude of motion, amplitude of SHM. Omega is angular frequency. Root K by m is angular frequency. Class 12 CBSE result to be declared.
So today at
Today?
2 p.m.
Today at 2 p.m. Yeah, I just got a notification. Very nice. Okay, all the best. So this is on the basis of internal marks, right? And pre-board marks.
सर सबके 95 से ऊपर ही आने हैं।
कैसे पता?
सर एक दोस्त से पता चला था, वो कह रहा है कि सारे टीचर्स मतलब उसकी मॉम स्कूल में पढ़ाती है तो सबको स्कूल अपने मार्क्स अच्छे करने के लिए सबके 90 से ऊपर रख रहा है।
क्या? ये कुछ क्राइटेरिया था ना, कुछ 11 के मार्क्स, कुछ 10th के मार्क्स, कुछ 12th के मार्क्स, ऐसा कुछ था बीच में क्राइटेरिया. डोंट नो. God knows what exactly is
30
the criteria.
40 करके कुछ था।
हाँ तो खाली 11th के मार्क्स थोड़ी चेंज हो जाएंगे अब. बट खैर वो शायद स्कूल ने सबमिट नहीं किए होते हैं तो कुछ भी हो सकता है.
जी सर।
Anything can happen. It's okay. Phi is the initial phase. What is this initial phase angle? That we have to understand because every SHM can be represented on a circular motion as well. Excuse me. Just a second. So when a body starts SHM, it starts from mean position, goes to the plus a maximum value, then it comes back to the same mean position, then goes on the negative side, and so this is the path that it takes. Start from mean, mean to extreme, extreme to back mean, mean to other extreme, and then come back to the same position. That is the overall motion. This motion is also represented or can be represented on a circular motion, based on phasor diagram or phasor relation. So what is phasor? हमने AC में भी पढ़ा है क्लास 12th में, voltage phasor and current phasor. Phasor is a vector which rotates with the same angular velocity as the angular frequency of SHM, and that's why we use the same symbol. Phasor की length होगी amplitude के equal, the radius is same as amplitude. Initial में इसका जो angle है from the reference position, that is phi, and that is why phi is called initial phase angle, because it represents the initial angle made by the phasor, and it rotates with that constant angular velocity as the angular frequency of SHM. Length of this phasor is same as amplitude, initial angle is same as initial phase angle, and angular velocity is same as angular frequency of SHM. Right? So after time t, where it will reach, time t is equal to t, the extra angle that is covered is omega t. Now, this phasor is used to represent the equation of SHM or displacement. How does it represent the displacement? Drop a perpendicular from the phasor to the opposite diameter. Drop the perpendicular from the phasor. तो पहले हम क्या करेंगे, जितना ये अंदर एंगल लिखा हुआ है ओमेगा टी प्लस फाइव, this whole is called phase angle at time t. From the initial position इतने एंगल पे phasor को rotate करेंगे, and from that position drop a perpendicular. The length of perpendicular dropped from the phasor represent the displacement. The length of perpendicular dropped from phasor represent the displacement. So ये perpendicular हो गया, A is the hypotenuse, perpendicular upon hypotenuse is sin theta, so that represent. But now since this phasor is rotating on a circle, so it can lie in any quadrant, first, second, third, fourth. That will be decided by the location. That will be decided by the location in which location or which side this particle is there. Yeah, so when the particle is starting from mean, okay, I'll take another diagram. Maybe this is the real equivalent phasor diagram. When it is starting from mean, so that means the initial perpendicular length has to be 0. So initial phasor is along here. This represents the mean position. As the particle move from mean to extreme, this phasor also rotate, and the length of perpendicular is increasing. It reaches to x equals to a. 0 to a, x equals to 0 to x equals to a. This will be represented in the first quadrant of phasor diagram. So if there is a particle lying between 0 to a and it is moving towards the positive a direction, then it will be represented in the first quadrant on the phasor diagram. अब उसका phase angle पता करना है, so that will be the initial angle from the x-axis. What is the displacement of that phasor particle? That particle, उसके लिए हम perpendicular drop करके perpendicular की length calculate कर लेंगे. When it comes back from extreme back to mean, then it will be the length of perpendicular should be decreasing. second quadrant when it is coming back to the mean position and right. So then the length of perpendicular will be decreasing. It will be represented in the second quadrant. When particle goes from 0 to other negative direction, that will be represented in the third quadrant because the length of the perpendicular will be decreasing. And then again it comes back to same. So that will be represented in the fourth quadrant. So when a particle is moving on a SHM path, then we have to see two things: where does it lie and which direction it is moving, towards the mean position or towards the extreme, right? So for example, if a particle is let's say x equals to, so phasor diagrams से फायदा क्या होता है? Let's first figure out this and then maybe we will. किसी भी SHM को circular motion में represent करने का फायदा, when we write the equation in SHM, that is not a constant velocity motion, it is not a constant acceleration motion. So what happens is that this motion is not, cannot be directly applied the equation, and we have to all the time write, all the time the equation x equals to a sin omega t, calculate time, and the trigonometric calculation is quite complicated one. So हम अगर suppose हमें किसी दो position के बीच का time निकालना है, let's say in SHM we have to find the time taken from x1 to x2, this generally start at x1 p and goes till q. So what we do in the equivalent phasor diagram, represent those phasor. x1 कहाँ पर होगा? Sorry, position p will be at first quadrant क्योंकि वो mean position से extreme की तरफ जा रहा है 0 to a. So p will be somewhere in the first quadrant where the length of perpendicular is x1. And then on the other side it is going to x2. x2 will lie in the second quadrant. This perpendicular length will be x2. If we can find out the angle between them, which is the phase angle theta, the time taken from P to Q, it will be very simple because theta is equal to omega t, so that will be theta by omega. Instead of applying that as SHM, this is the phasor method. We will represent that position in phasor diagram. दोनों phase के बीच का angle निकालेंगे. And since circular motion is with a constant angular velocity, so time taken is theta by omega t, theta by omega, because theta is equal to omega t. Excuse me. अब इसको एग्जांपल समझते हैं, ऐसे शायद थोड़ा समझ में नहीं आएगा. वन कंप्लीट टाइम पीरियड ऑफ SHM, तो वैसे हम मैथमेटिकल इक्वेशन से भी कैलकुलेट कर सकते हैं क्योंकि साइन का पीरियड होता है 2 पाई. Sin x is a periodic function, cos x is a periodic function with period 2 pi, that is the graph. After every 2 pi it is repeated. Similarly, cos is also there. Cos and sine both are a periodic function, and that period is repeated after every, that function is repeated after every 2 pi. ये maths में पढ़ा ही है आपने. Now, if a function becomes sine 2x, sine 5x, sine 3x, cos 2x, then also it will be a periodic function. Only thing that will change is the period will change. Like suppose if it is sine 3x. So sine 3x का मतलब क्या हुआ? The value which was earlier obtained at x equals to 2 pi, now that value will be at 2 pi by 3. So वो function पहले से shrink हो गया. This has, पहले जो value मिल रही थी x equals to 2 pi पे, now that value is at x equals to 2 pi by 3. So this length, which is the time period, has now reduced. It become 2 pi by 3, which was 2 pi when the function was sin x. So in general अगर हम एक mathematical equation से निकालना चाहें, so when it is sine of t or cos of t, then the period of that function is 2 pi. When it is sine at or cos at, when there is some coefficient, then period is 2 pi by a. When the function is sine square t or cos square t, because it is square, so negative वाला भी positive हो जाएगा. So sine square or cos square के लिए period will become exactly half, because it will start getting repeated after every pi interval. So if it is sine square t or cos square sine square at or cos square at, then it becomes pi by a. बट ये मैथमेटिकली थोड़ा मुश्किल है हमारे लिए समझना और अंडरस्टैंड याद रखना. सो मतलब ये तो स्टैंडर्ड है, बट सपोज इन बिटवीन जैसे यहाँ से यहाँ तक कितना टाइम लगेगा, सो दैट विल बी वेरी कॉम्प्लिकेटेड. इसलिए हम यूज करते हैं बेटर, एंड दैट बेटर मेथड इज वी ऑलवेज प्रेफर यूजिंग द फेजर मेथड. सो x इक्वल्स टू a sin ओमेगा t प्लस पाई, इसको हम अगर ऐसे समझेंगे तो 2 पाई बाई ओमेगा बिकॉज इट इज sin 80 टाइप्स. But if we consider a circle motion, the circle में हमें पता ही है that every one complete circle time taken is 2 pi by omega. So what is the time period? One complete rotation means 2 pi by omega. Starting from mean to come back to the same mean position. So by that logic, suppose if I ask what is the time taken from mean to extreme. So mean to extreme मतलब एक quadrant पूरा cover करना 0 से a. वैसे तो ये खैर equal भी divide हो रहा है. So time taken will be 0 to a is t by 4. Time taken from mean x equals to 0 to extreme position. Mean से extreme तक जाने का जो time है, that is 1/4 of the total time, t by 4. Because it is 1/4 of the journey also, so by that logic also we could have guessed it. But suppose if we ask what is the time taken from 0 to a by 2, so ऐसा लग सकता है that this is again half of this whole journey. So it will be t by 8. It will be t by 8, but it's not t by 8 because it is not moving with constant speed or constant velocity. Only if it is moving with constant speed or constant velocity, then we say that it will be distance half, then speed time again will be half. Here what we need to do, 0 to a by 2, so we'll have to find that phasor position where the length of perpendicular is a by 2. Vedika, you understood this phasor diagram, phasor method? Vedika? Are you there in the class?
Yes, sir.
What happened?
Nothing, sir. I was drinking water.
अच्छा नहीं, मैं ये पूछ रहा हूँ समझ आ रहा है ना ये? यू
यस
यूज
सर।
डाउट्स बट अभी कुछ टाइम से डल सा है
सर
मामला।
ये समझने में थोड़ा टाइम लगता है, मतलब समझ आ गया बट हाँ रिटेन कर लूंगी जो ऐसे भी।
समझने में टाइम लगता है, व्हाई दैट टाइप ऑफ बिलीफ नहीं समझ में आया तो क्या ना उसके लगता है,
नहीं नहीं
डोंट
सर,
मेक इट अ
आ
टेंडेंसी
गया।
फॉर psychological, and that's why physics seems strange sometimes, because if it is easy and it is you have already assumed is difficult, it will appear difficult only.
सर
Yes boss.
सर पता नहीं सर, आपकी आवाज बहुत कम आ रही है।
मेरी आवाज बहुत कम आ रही है, ये सबके साथ है या?
नहीं सर ठीक आ रही है मेरे को तो।
बीच बीच में
थोड़ा
धीरे
वॉल्यूम
है
बढ़ाओ।
बट वैसे ठीक है।
ओके राइट, सो फेजर डायग्राम यूज करके टाइम कैलकुलेट करना इज क्वाइट इजी एज कंपेयर टू यूजिंग द इक्वेशन। अनन्या, यू अंडरस्टूड, गॉट इट?
Yes, sir.
तो अगर हम 0 से a/2 तक के लिए टाइम कैलकुलेट कर रहे हैं, what we have to figure out that what is the angle that phasor has rotated from 0 to a/2 by using some trigonometry. What will be this angle theta? Vriti, what will be this angle theta? Vriti,
Yes, sir.
what is the angle that the phasor has rotated from x equals to 0 to x equals to a/2?
A by 2 omega.
No, no, no. I'm asking this. Now, when you drop a perpendicular, the length of perpendicular is a/2. Hmm? That will be time taken. Time taken is theta by omega. We want this angle. So perpendicular in this right angle triangle is a/2 and hypotenuse is a. So sin theta is how much? Perpendicular upon hypotenuse, right? Vriti,
Yes, sir.
perpendicular upon hypotenuse, half. So you have to find this angle in terms of like 30 degrees, 60 degree, pi by 2, pi by 3, pi by 6. So it will be some numerical value. What is this angle then? Theta is? What is this angle? Theta is? Vriti?
30.
30. So in the radian, it will be how much?
Pi by 60. Pi by 6.
Pi by 6. So that angle that the phasor has rotated from 0 to a/2 is pi by 6. Time taken is theta by omega. So that will be pi by 6 omega. If we want to write this in terms of, total time period, the time period of this function is 2 pi by omega. Time period of this motion is 2 pi by omega. So we can write this as multiply by 2 in the numerator and denominator. So that becomes 1 by 12 times 2 pi by omega. So time taken is t by 12. If mean to extreme time is t by 4, so mean to a/2 time taken is not t by 8, it is t by 12. And the easier way to get it by using the phasor diagram. There are other methods also, but this become easy because you just need to find this. Angle here. Right?
यस सर।
Okay. So what is the time taken from a by 2 to a? 3/4 से माइनस करके निकाल सकते हैं या फिर हम अगेन फेजर डायग्राम की हेल्प ले सकते हैं. From a by 2 to a, we can take phasor diagram. Yuta,
Yes, sir.
what is the time taken from a by 2 to a? I think I asked, we discussed that you will come offline for the tests. Yes, so anybody who is ready and willing to come for offline tests, Monday onwards, you can come or you should come. Those for those who can come.
Sir, timing?
Timing, beta, after one anytime, it will not be a class. I will not take any class or doubt. We'll just give you a paper and you will sit and solve a paper because, especially for the NEET people, because their exam is offline. So online JEE and also you can come, but yes, if you want to come, I shall be available there Monday or Tuesday onwards. So I'll confirm on the group as well. Don't worry. So paper practicing is a different thing at home, and attempting a paper in the exam scenario, exam environment is an entirely different thing. You might have experienced. So when you sit in the exam hall or in some different environment, not at your home, a lot of other factor also comes to play. So you should try to simulate. There's one student in my class 12th group last year. When he does the paper at home without any cheating, because I have monitored that, he is able to score 230 out of 300. I'm not because we taking an individual class, not in the this group. And in the exam, J exam, he is not able to even touch 170 because of the fear factor, because of so many other things. And he doesn't know what is the reason. And what reason means, according to him, all the questions I have done correctly, and so and so. It is just the subconscious belief or temperament or whatever it is that is not allowing you to perform because you are not conditioned for that unknown environment. With the comfort of your home, everything seems so easy. So night. T by A by 2 to A by 2 to A, the angle covered is how much? 60. 60 can be pi by 3. So time taken from A by 2 to A, we can write pi by 6 omega. Sorry, I think I have written it opposite. Pi by 6 here and pi by 3. It is 60 degree. So time taken from A by 2 to A, that will be pi by 3 omega, or we could have directly subtracted from the total time. That will become 1 by 6 times 2 pi by omega, so t by 6. So since total was t by 4, so t by 4 minus t by 12 would also have given the same answer. Right? Similarly, from any point to any other point, we have to find the time taken, we can calculate. So let's say find the time taken by a particle. ये phasor diagram जो हम बना रहे हैं circle, वो हम अपनी convenience के लिए बना रहे हैं. It's not anywhere in the actual path. Find the time taken from x equals to a by root 2 to x equals to minus of root 3 a by 2. So a by root 2 will be in which quadrant? So the path that it is asking is the time from a by root 2 is lies in the first quadrant and x equals to minus root 3a by 2 in this third quadrant. So start from mean to extreme, come back. Right. So हमें p को represent, sorry, we have to find from here, not from the 0, from this position. We have to represent the phasor of p, we have to represent the phasor of q in the phasor diagram, and then we need to find how much is the angle covered. Can you try, please? Especially Vedika, try this. A by root 2 say minus root 3 by 2. Need to find the yes, try find the phase angle of P and phase angle of Q.
So, so
Yes, Vedika, done?
no, so it's me Ananya.
Yes, Ananya.
So I'm getting 5t by 24. I'm not sure it's right, but I got 5t by 24.
50 by 24. Okay, let's check. Vedika, what is the phase angle of P? P lies in which quadrant? Vedika,
Yes, sir.
P lies in which quadrant? Why you are so dull? Not well. P is in which quadrant? Out of these four, mean से extreme की तरफ जा रहे हैं. Which quadrant it will lie? Yes.
So second,
Second. Okay, come back here. When we go from mean to extreme, that is first quadrant. When we're coming back to mean position, is second quadrant. We are going to the negative extreme, that's third quadrant, and coming back to mean position is fourth quadrant. That is the simple diagram that you can understand. So 0 to a by 2. A, this will be in first quadrant. When you go from mean to extreme, this will be in first quadrant. There is another very long mathematical method. I want you to try to learn this method. It is quite easy. हमने point P की location देख ली, वो mean से extreme की तरफ जा रहा है, and it lies in the first quadrant, which is it. And the perpendicular drop should be of length a by root 2, क्योंकि perpendicular represent करता है displacement. By that logic, what will be this angle? Sin theta is perpendicular upon hypotenuse.
So 45 degree.
45 degree or pi by 4.
Yes, sir.
Right? 45 degree or pi by 4. Vedika, is this clear?
yes, sir.
In which quadrant Q will lie then? Vedika, which quadrant lies, Q lies in which quadrant? Yes. Vedika, I'm asking you, Q lies in which quadrant? First, second, third? Q will be in third quadrant. And the length of perpendicular should be root 3a by 2. Sine theta is root 3a by 2. So that means 60 degrees. 60 degree means pi by 3. So here in this diagram, perpendicular Q lies in third quadrant, root 3a by 2, 60 degree, pi by 3. So P से Q तक इसने total कितना angle cover किया, हम वो angle निकाल लें, and then time taken will be theta by omega. So theta is either pi by 4, that will become pi by 4, plus it is pi by 2, plus it is pi by 3.
Yes, I did it wrong. I did the third quadrant thing wrong. Okay. So it's not
Okay.
5t by 24. It's wrong.
Right. So
I
here
changed
you'll
my
put
answer.
12, so that is 3 plus 6 plus 4 by 12 times pi. 13 by 12 pi. Siddharth? Mr. Siddharth? Thirteen t by 24. Okay. Yes. Harsh?
Yes, sir.
Understood?
Yes, sir.
Okay. If there's any doubt, you can ask. हमने दोनों position को phasor diagram में represent करना है. We have to find the phase angle between them. So जैसे question जो आया था हम उसकी बात कर लेते हैं. The question that was asked. There are two different SHM. At a position of a by 2, those two SHM are crossing each other. P is going towards right. Find the phase difference between P and Q. Find the phase difference between P and Q. I think Vedika, you need to do this revision of this topic again and with a very detailed approach. If you didn't understand this, so we can take the help of those video lectures that I shown last class. I'm just sharing the link again on the group. Those who want can download and check.
सर लास्ट
in
के कुछ डेज की पीडीएफ भी नहीं आई है.
लास्ट के कुछ डेज की पीडीएफ भी नहीं आई है. Okay. वो तो मैं अभी शेयर कर देता हूँ. वेट. Okay.
लास्ट 1 वीक.
Last 1 week. 27, 26.
22 की आई है लास्ट जो आई है.
Hmm. Okay, 0 to a by 2 और a by 2 से सो हमने क्या करना था, फेज डिफरेंस यहाँ पे निकालना है इन दो पार्टिकल के जो a by 2 पे अपोजिट डायरेक्शन में क्रॉस कर रहे हैं. दिस क्वेश्चन इज आस्क्ड इन जेईई एज वेल एज नीट. मैथमेटिकली करोगे थोड़ा कॉम्प्लिकेटेड है, तो अगर हम इसको फेजर मेथड से करते हैं इट इज वेरी इजी. हाउ p will be in, Vedika, p will be in which quadrant, first or second?
So first,
First, with the perpendicular length as a by 2. q will be in which quadrant?
fourth,
q lies in which quadrant? q.
uh, third.
बहुत सिंपल है, आप ज्यादा शायद सोच रहे हो, ज्यादा इसको डिफिकल्ट ले रहे हो. मीन से एक्सट्रीम फर्स्ट, वापस आएंगे मीन पे तो सेकंड, उसी तरफ जाएंगे तो थर्ड, वापस तो फोर्थ. So q is in which path? Returning back to mean position. Which quadrant will be this?
Second.
Second quadrant. And again, since it is at the same position a by 2, so perpendicular length will be a by 2. हमें ये angle find out करना. This angle is the phase difference. ये a by 2, a 30 degree, 30 degree means pi by 6. Here also pi by 6. So दोनों के बीच का जो phase angle है, that phase difference will be pi minus 2 times pi by 6, which is pi minus pi by 3 or 2 pi by. The phase difference between these two positions is 2 pi by 3. Got it? Yes.
Yes, sir.
Hmm.
सर
Yes, बेटा बोलो.
सर ये वाला एक बार फिर से बता दीजिए, थोड़ा कंफ्यूज हो गया सर. आपने जो बताया था मीन से एक्सट्रीम में जाएगा फिर तो कोऑर्डिनेट ऐसे चेंज होगा.
Mean से SHM, sorry, mean से extreme तो first quadrant, extreme से वापस back mean पे तो second quadrant, mean से negative extreme में तो third quadrant में lie करेगा और extreme से वापस mean पे तो fourth quadrant में lie करेगा.
ओके सर, गॉट इट.
Yes. ठीक है, तो ऐसे हम फेजर मेथड से क्वेश्चंस कैलकुलेट कर लेते हैं. फेजर मेथड इसको एक बार रिवाइज करना. डाउट है तो कल फिर से, नहीं कल तो क्लास नहीं है, नेक्स्ट क्लास विल बी ऑन मंडे. So I have shared that application WhatsApp on your WhatsApp, the application link. If you want, just by paying 2 rupees, you will get the access to all these extended recordings of the batch. So there are more examples. You can go through it. Okay, Vedika, it's not difficult. You are just taking it very difficult. It's very easy. But this method, if you understand and you start using the phasor method, the questions will become very, very, very quick, and it will be very easy for you to solve the correct answer. Because in the sine and cos, there is a lot of pain. Sine and cosine, because of being
सर फेजर हमेशा से एक वीक रहा है मेरा, इसीलिए मुझे.
आपके बिलीफ थोड़े गलत हैं. हमेशा से मुझे वीक रहा है. चेंज योर स्पीच पैटर्न. जो रहा है वो चेंज भी हो जाता है. When you put effort, वो रहा होगा. अभी you are doing it, you are putting effort, it will be changed. Your speech pattern decides a lot. Change it. मुझे बहुत
Okay.
टाइम लगता है समझने में. मेरा हमेशा से वीक पॉइंट रहा होगा. ठीक है, अब थोड़ी रहेगा, because now you are working on it. Understood? So change your speech pattern like this. Okay, I will finish this today. Phaser method, and I'll solve all the questions. And I will do it. Because you are learning. जो पहले state था वो state थोड़ी है. अब आप उसको सीख रहे हो. You are trying to learn, but with this mindset that yes, I will be able to do it. You are speaking some negatively. ये रहा है, ये कैसे समझ में आ जाएगा एक बार में? No, that's wrong approach.
Yes, sir.
If it is understood in the first time, maybe you have to revise 2-3 more times, but it will be easy. रहा होगा जब कभी रहा होगा. अभी आप पढ़ रहे हो, नहीं समझ में आता है, then obviously I am here. But don't have this attitude. ये तो मुश्किल है, ये तो रहा है, ये तो होगा. Nonsense. Okay, then we will meet on Monday. Thank you. Bye bye. I have shared
Okay,
this
sir.
today's lecture
Thank you,
also.
sir.
और कुछ कह रहे थे आप?
नहीं सर, थैंक यू वेरी मच.